Hi everyone. Today we are going to continue the topic sets, under which we are going to discuss the topic Venn diagrams. So Venn diagrams, we have already discussed that a universal set is represented by a rectangle and a subset of a universal set is represented by a circle inside the rectangle. So this is a representation of a Venn diagram, right? So if there are two subsets, let's say A and B, two sets, then universal set is represented by this rectangle, and this represents the common intersection points. That is, the elements which are common to both the sets A and B are represented by this common intersection, right? Now, for like in mathematics, we do operations like addition, subtraction, division, multiplication. Similarly, we can do some operations on the sets as well. So how these are, what kind of operations we can perform on sets? So there are broadly there are three operations which we can perform over in the sets. The first is the union, then is the intersection, then is the difference. Right? Now union of sets means we combine all the elements together. Union of two sets, for example A and B, is represented by the symbol A union B, and we write this as all the elements of A and all the elements of B together. They are written in the set that represent the union of A and B. For example, if A is equal to 2 4 6 8 and B is equal to 6 8 10 12, then union of A and B is written as all the elements of A, 2 4 6 8, and then these 6 8 are already included, then 10 12. So this represents the union of A and B. Now in the set builder form, we can represent this as x A union B is equal to x belongs to A or x belongs to B. Now this we have as or, right? In the intersection it will be and. Now which we will be discussing further. So now these are some properties of union of sets. So A union B is equal to B union A, means these are commutative. Commutative means what? If we do A union B or if we do B union A, the result will be same. Now if A union B union C, first we do the union of B and C, and then we do operation with A union with A, then or we do A union B first and then we do union with C, both the results will be same, right? Then another property is A union phi. Phi is a null set or empty set, so this will be giving you the same result only, A, all the elements. And then A union A will be A. This is the idempotent property, and this universal set union with A will be yielding you universal set only. This is the law of universal. Now intersection of sets. Intersection we denote by the symbol A, the ulta U है, फिर B. Achha, this indicates the common elements of both the sets, right? So for example, if A is equal to 2 3 5, B is equal to 4 5 6, then intersection of both will be the common element which is in both. So this is 5, right? Now if B is a subset of A, then A intersection B will be B. Means what? B is a subset of A means B has elements which are there in A as well. So both का intersection कौन सा होगा? जो B में elements हैं वही आ जाएगा symbol. So this is that representation only. So if A intersection B is equal to 5, then A and B are disjoint sets. Disjoint means they have nothing in common, right? So these are the properties of intersection of sets. If A intersection B is equal to B intersection A, means either way you do, the result is going to be same. So A intersection B intersections with C, पहले A का intersection B के साथ करें और फिर C के साथ करें, और या फिर पहले B का C के साथ करके फिर A के साथ करें, the result is going to be same. Then phi intersection A, phi means null empty set intersection with A will be having no element in common, so this is phi, right? Universal set with A, it will be A only. A intersection A will be A again. A intersection B union C, this is a property now. So जो universal जो intersection है, that becomes दोनों का करके, मतलब पहले A का B के साथ फिर A का C के साथ intersection, and then result becomes the union. This is the dissociative property. So these are the properties which we can remember, right? another operation we can do on sets is the difference of sets. Now A minus B indicates what elements which are in A but are not in B. Now see, for example, A is a set having three elements 1 2 3, B is equal to 1 3, then A minus B will be having the element which are in A but not in B, so this is 2, right? So this becomes 2. And if we do B minus A means elements which are in B but not in A, so there is no element, right? Because 1 is also there in A, 3 is also there in A, so there is no element which is not there in A, so this is 5, right? So one weekend conclusion we have drawn that A minus B is not equal to B minus A, right? And then another property is there, A minus B, A intersection B, B minus A are mutually disjoint sets. Now we can say this is a Venn diagram representing, so this is, let's say for example, this is set A, this circle, and this circle is set B. So A minus B represents this area, intersection wala se bhi idhar wala area, this represents the A minus B. This is the intersection area, A union intersection B, and this represents B minus A. So we can see that there's nothing common in these three areas. So this is nothing but we say this as mutually disjoint sets.